Hello, my friends, and welcome to exercise number 83. In this exercise, we are going to implement the perfect binary tree, and we will create a new Java class called perfect binary tree. By the way, you can download all of these source codes for this course from the resource folder under every lesson. Okay? Since we are dealing with a tree, we need to create its basic building structure, which is a node. So we start by static class node, and we are dealing with a node of a tree. We have to make a key or data structure that we are going to store data inside it. So it is of type int. And I name it as key, or you can name it as data. I prefer key because we are working with trees. And I will create a reference node to the left and a reference node to the right. Okay? This would be like a pointer to the left and a pointer to the right. Okay? Now, in the perfect binary tree, we have said that the depth is very important in order to determine the structure of this binary tree, if it is a perfect or not. So the depth is very important. Before we start creating a depth, let me create a method that creates a new node. So despite making a new constructor for this perfect binary tree, I will make a new method called new node, and its returning type is node, and it took into the parameter the int k. So when we are going to create a new node, we are going to deal with this new node method, not with a constructor. Creating a node. This is the empty constructor, and we start by initializing the key equal to the key that it is passed. So here we are storing the data inside the node and initializing the node dot right equal to null and node to the left equal to null. Okay, in this way we are creating the node, initializing its right and left to null, and inserting inside the key the passed parameter. Okay, it's very simple, and in this way we are making everything looks perfect. Now let's start calculating the depth. So static int depth took into the parameter node, and we start by making an int d equal to 0. We start while looping through all the nodes in order to determine the depth of the tree, d plus plus, and we move the cursor node dot left by 1 every iteration, and then we return how much it will be the depth. Now let's create a new method that checks for the perfect, and this is what we need. So check if the tree is perfect binary tree. Static boolean is perfect, and we call node, it is root, int d, and int level. These are the parameter of this function. We start by calculating the root, start from the root, which is passed, and we start with D, which is the depth, and we also get the level. How to get all of these parameters? So let me tell you by checking at the first if the tree is empty. So every argument of this parameter of this function will refer for us for checking, and it's used for checking. Like if the root equal to null, then this tree is empty. So if root, then return true. Okay, and we have said that a single node is a perfect tree. It's very simple. Okay, now if for children, if root dot left equal to null and root dot right equal to null, then return D equal to level plus 1. We are checking if D equal to level plus 1, which is the past parameter. If D equal to level plus 1, then return true. Otherwise, it will return false. So we have this check, we have this check, and now we are going to implement another check that it assures that the nodes are at the same level. No nested nodes at the left, and there exist at the right nested nodes, or vice versa. So it assures that and ensures that all the nodes are at the same level. So root dot left doesn't equal to null, or if we have a root dot right equal to null, if any of these would equal to true, then it will return false, because we don't accept any left nodes, like at level 5, and at level 4 there is the right. Or we have at the left subtree has at the left level 4, and at the right we have level 5. They are not accepted. Please go back to the previous video for the lecture in order to understand it better if you have any problem. Otherwise, it will return is perfect recursively. Start testing all of these by passing root to the left, D, and level plus 1. Okay, and is perfect root to the right, also checking for D, and level plus 1. Okay, it's very simple, and we are checking with the AND operator recursively that is perfect, this and this Boolean expression and this Boolean expression. If it is true here and this is true, it will return true. Otherwise, if any of these is false or both are false, it will return false. This is how we check for the perfect binary tree, by changing this, by using this algorithm and comparing the Boolean expression to the left and to the right, and checking the root levels and the depth of each of these subtrees. Now let's make a wrapper function that it may be maybe confusing for you, but it's very simple. We are just making it to like prettify our code. So it took it to parameter the root and just called the perfect method that we have created before, but we calculate also the depth root, and we return is perfect, and we pass the root, we pass d, the depth, and we start from the level z. Okay, this is like a template or a general calling of our function is perfect. Now let's create a driver class called the main method. Sorry, public static void main string args node root equal to null, and or you can create it directly here, new equal to new node, new node, new node. We are calling the method called a new node because we don't have any constructor. The default constructor we have used it in here. So we initialize the left to new node 2. We have a root to the right equal to new node 3. Root to the left equal to new node 4, and root dot left dot right equal to new node 5. Now let's check if is perfect. We pass perfect with capital P. We pass the root. If it is equal to true, it returns true, or we can make it like this. It will print for us system.out.print ln the 3 is a perfect binary tree. Otherwise, it will return else. It will return is not a perfect binary tree. But before we starting this program, let me show you what this means, what we have done. We have the node, the root here. Sorry. One. We have to the left 2. We have to the right 3. We have to the left, which is, this is the left, and the left of it we have 4. We have left, and this is the left, the first left, and we have the second thing is right. So left, right is equal to 5. So tell me, guys, in the comments below if this is a perfect tree or not, perfect binary tree or not. And I think you guess it because they are at not at the same level. So nodes are not the same level. It is not a perfect tree. Let's run and see. And here we go. The tree is not a perfect binary tree. So we have solved this exercise number 83, and we have created our perfect binary tree, and we have created this method that checks if it is a perfect binary tree